Hi guys, I hope y'all are doing well. I'm gonna help you guys go through chapter 5 exercises. Okay, so for these, I assigned number 1. So for a binomial with n of 25 and p of 0.5, determine a, b, and c. So the first equation reads p hat is greater than or equal to 15 over 25, which is at n. So on this one, we're just going to use that p binomial function. So p binomial of, remember it's 15 constant and 25, which is the sample size, and the probability is 0.5. Okay, enter, and you should get 0.88. Okay, so now for the next one, it's p hat less than 15, 25. So for this one, we're going to be doing 1 minus that p binomial of, again, 15, sample size of 25, and probability of 0.5. Okay, enter. And the last one reads 10 over 25 is greater than or equal to p hat greater than or equal to, so between 10 and 15, that's the probability. So for this one, we've done something like this, or similar like this, or the same thing. So you're going to be doing 15, 25, and 0.5 minus, again, p binomial of 10, 25, and 0.5. Oops. I did something wrong. Oh, okay, I forgot that n. So again, up arrow, and I'm gonna put the n here. Oh, I'm sorry, no, it's not there. It's fine. Okay, so I should enter, and you should get 0.67. Okay, so now for number 2. Many research teams intend to conduct a study regarding the proportion of people who have colon cancer. If a random sample of 10 individuals could be obtained, and if the probability of having colon cancer is 0.05, what is the probability of a research team that the research team will get a p hat of 0.1? Okay, so for this one, they usually use the table in Appendix B, but we're going to be using the d binomial function. And for this one, it's going to be the possibility of success or failure, or in this case, of having colon cancer, of not having colon cancer, so 1 having colon cancer, and the number of individuals, so 10, and the probability, which was 0.05. Right, so you should get 0.30. Okay, now for the next one, I believe is number 4, which says someone claims that the probability of losing money when using an investment strategy for buying and selling commodities is 0.1. If this claim is correct, what is the probability of getting p hat of greater than or equal to 0.05 based on random sample of 25 investors? So for this one, you need to again use that success or failure. So 0 is failure, success is 1. So for this one, we're going to be using the p binomial function, and it's going to be the probability of losing money, I believe. So 1, and the sample size is 25, and the probability of losing money in an investment is 0.01. So 0.1, I'm sorry, 0.1. Okay, so that one should give you 0.27. That's the probability. The next one is number 10. Okay, so someone claims that with a certain neighborhood, the average cost of a house is mu 100,000 with a standard deviation of 10,000. Suppose that based on 16 homes, which is N16, you find that the average cost of a house is X bar 95,000. Assuming normality, what is the probability of getting a sample mean this low or lower if the claim about the mean standard deviation are true? So for this one, we will be doing P norm. So P norm, assuming that the deviation is normal, and it is the constant, which is 95,000, right, X bar, 95,000. The mu, the median was 100,000. And the standard deviation was 10,000. Remember the formula calls for the square root of the sample size. So in this case, our sample size is 16. And if we get the square root of that, it's 4. So we're going to be doing divided by 4. Okay, so that one should give you 0.022. Okay, so for the next one is number 11. In the previous problem, what is the probability of getting a mean between 95,500 and 102,500? Okay, so again, we've done something similar to this one. So it's going to be key norm. So one symbol like that, we're going to use this one. And it's going to be the probability of it being between these two values. So 102,500. The mu, the mean is the same, so 100,000. 100,000, right? It's okay. And then again, we're going to do the same thing. So it's going the standard deviation is 10,000 divided by that 4. And we're going to do minus P norm of the other one was, what is it? 97. 97,500. Again, the mu was 100,000. And the standard deviation was 10,000 divided by that 4. Okay, so that should give you 0.68. Now the next one is number 18. For the values for 4, 8, etc., verify that the McKean-Starter estimated standard deviation of error medium is 7.57. So that one, we're going to input all of those values into X. So it was 18, 4, 8, 23, 43, 12, 11, 32, 15, 6, and 29. Okay, store those into that X, and now we're going to use that function, which is MSME DSE X. Oops. Did I spell it right? DSE X. Okay, I think I haven't downloaded the packages yet. So I'm gonna go ahead and just do source file.choose. Sorry, is every time that I close the application, it deletes all of my packages that I already had downloaded. So it's gonna happen every time. So I'm gonna go ahead and just look for that text I have saved already. So I saved it in downloads. Where are you? There you are. And should be this one. There it goes. And now I should be able to do, oops, it's not gonna work because MEDSE X. Okay. There it is. It's like, why isn't it? So it's 7.57, that's correct. And now for the next one, which was number 20, I believe. For the values, etc., verify that the, okay, so it's the same thing, is 97. So we're gonna do it, go ahead, X, combine, and just store all those values into the X. So it was 5, 7, 2, 3, 4, 5, 2, 6, 7, 3, 4, 6, 1, 7, 4. Alright, so we're gonna do that same function, X. Okay, and it should give you this. Remember that I talked about the tied values and how it is inaccurate if you have the same values repeated. So it still gives you the 0.97, but it's telling you, that it's inaccurate. Okay, so now the next one was 25. So for the values, the following, estimate the standard area of a 20% trend mean. So we're gonna go ahead and store all those values again into that X. So it was value 59, 106, 174, 207, 219, 287, 313, 365, 458, 497, 187, 515, 529, 529, 557, 615, 625, 645, 973, 1065, and the last one, 32. Okay, a lot of values. Okay, so we have all those stored there. Did I move anything? Sorry, so it's kind of hard to, there you go, because I have like the stop sharing button right under this one, so it's hard to click. There you go. So I don't think it changed anything about the values. And now we're gonna do the, I think it was the trim mean or something, the function 25. Yeah, it's trims X. And it should give you 69.38. That's the trim. So they're trimming the 20%, which I'm assuming it's these values right here, the larger values. Okay, so the last one is number 30. And I'm sorry, I did 25. 28 is next. Okay, so under normality, the sample mean has a smaller standard error than the 20% trim mean or median. If observations are sampled from a distribution that appears to be normal, does this suggest that the mean should be preferred over the 20 mean and median? Yeah, so for this one, I'm gonna go ahead and let you guys answer it since it's not computational. And I'm going to move on to the last one. Okay. So it says, observations can be generated from the distributions in figure 5.4a using the R command RL norm. For example, RL norm 25 would generate 25 observations. Indicate the R commands for determining the sampling distributions of sample medium M. In particular, how would you determine the probability that M will have a value less than 1.5? Okay. So this one, it actually gives you a step-by-step on how to do it. I think it was like towards the end. Yeah, so it's in page 132. So if we follow that, we're gonna do median, because we're doing the median. Vals equals null and then we're doing for, remember no spaces, study in one. So we're doing, it's telling us you're doing, what is it, 10,000? 10,000 studies. So close parentheses, and I'm guessing it's leading one of those. I'm literally just following exactly how it says in the book. Okay, so now it says X. This is the first time I'm doing it, so I'm doing it with you guys. L norm of 25. Enter. And then median dot vals, and we're doing study, close parentheses, equals median X, and there's that close parentheses. Okay, so I'm just gonna press enter. Oops, cannot find function LR norm. So for some reason I don't have that function LR norm. X equals LR norm, right? Okay, well over here it actually says, I think it's weird. This one, I think it's like, I don't know if it'll do anything, since I don't know if I have to write the whole thing again for it to work, because I do think that it's supposed to be like this, and I put it yeah, right here. So maybe I'll try to do it all over again and see what happens. Dot vals equals no. Let's try the whole thing again. Enter for study in one. And we're doing, what was it, 10,000? 10,000, okay. And we're gonna do that bracket here. Okay, enter. So this is where I messed up the last time. X, R, L, norm, 25. And then median dot val, so values, study, study equals median X, and then close parentheses, and then, oh look, I missed the section, so median dot vals greater than or doing 1.5, and close parentheses. There it is. So that is what we get for that one. This is a probability that we will have the values less than 1.5, so it's 0.95. Okay, so if you guys have any questions, you guys can email me or text me. Other than that, I will see you guys in class. I'll keep up to date with everything. Yeah, so that's everything. Go ahead and exit out. Take care, you guys. Be safe. We'll see you soon, hopefully.